ahead and work it out. All right, so we're going to follow those instructions. We're going to calculate the ratio, the mole ratio, and do it that way. Okay, so it doesn't matter how you do it. In any case, you always have to figure out what's given and what's wanted. So let's just start like that. In this case, what's given is we have 55.5 grams of butane, and we also have 45.5 grams of oxygen. And what we want is we want to be able to figure out the number of grams of carbon dioxide that was formed in this particular reaction. Okay, and so we have to figure out the number of moles according to this method. We have to figure out the number of moles of butane that's given, the number of moles of oxygen that's given, and figure out the molar ratio there. And so how do you figure out the number of moles that are given? You, of course, use the molar mass to convert from grams to moles. So for butane, let's do it real quick right here. There's 55.5 grams of butane given, and we want to figure out how many moles that is, so we just divide by essentially the molar mass, or multiply by the inverse of the molar mass, which is 58. We figured that out on the last one. Grams of butane per 1 mole of butane. And so in this case we have about 0.957, let's say, moles of butane. And in this case we have 45.5 grams of oxygen multiplied by the inverse of the molar mass, which is 32 grams of oxygen per mole of oxygen. That'll give us units of moles, and we have 1.43, let's say, moles of oxygen. Okay, and so we're trying to figure out which one is our limiting reagent, which one are we going to run out of first on our way to producing the carbon dioxide. And so according to the instructions on the previous page, we first had to calculate the number of moles of each reagent, which we did right here, and then we have to calculate the available mole ratio. So I always put the larger amount over the smaller amount. So in this case, just because it's 1.43 moles of oxygen per 0.957 moles of butane, and that mole ratio is equal to, let me see, did I write that down somewhere? Oh yes, that's about 1.5. Okay, that's the molar ratio of oxygen to butane. Now that's the available molar ratio. But what's the molar ratio we need here to react away all of each of them? In that case, it's the needed molar ratio. I'm going to write it up here. Going off the balanced chemical reaction, the needed molar ratio to react away all of everything in the reactants is 13 moles of oxygen per 2 moles of butane, and that ratio is equal to about 6.5. Okay, so in order to react away all of the oxygen, I need it to be in a ratio of 6.5 to 1, and the ratio that's given here is only 1.5 to 1. That tells me that because this ratio is too small, it's too small compared to what's needed, that tells me that the oxygen is the limiting reagent. So that's going to control how much carbon dioxide I can produce, limiting reagent. What that means is I'm going to run out of oxygen before I can react away all of the butane. Okay, so so then in order to solve the problem, then you just go from use the given oxygen to the wanted carbon dioxide. The conversion path then is going to be from grams of oxygen to moles of oxygen to moles of butane to grams of butane. Excuse me, not butane, that's not what we're going for. Excuse me, I'm rushing. Moles of carbon dioxide to grams of carbon dioxide. All right, and then the conversion factors that you're going to need to go from here to here is from grams to moles, it's going to be the molar mass of oxygen. From moles of oxygen to carbon dioxide, it's going to be your reaction stoichiometry. And from moles of carbon dioxide to grams of carbon dioxide, it's going to be your molar mass of carbon dioxide. Okay, So you should be able to work out and get the answer, given all this information, as to the grams of carbon dioxide that are produced. So I'd like for you to stop the tape again and finish working this one out. And then when you start it again, it'll be part 3, and I will tell you the answer. Let's see if you can get it.